The universal compass. How a single mathematical proof unlocks the hidden geometry of the universe. At the heart of this geometric journey lies the derivation sheet, a foundational blueprint that proves a singular powerful truth: how to find a direction that exists entirely outside of a given space. This proof acts as an orthogonalizing engine, a logical machine that takes a set of directions and produces a new one perfectly perpendicular to all of them. While the derivation provides the underlying logic, the sequence and state diagrams map out how this engine drives our understanding of the physical world. The sequence diagram illustrates the purposeful flow of this logic as it transitions from abstract theory into reality. It shows that the process is not a collection of isolated facts, but a continuous evolution. The journey begins with the derivation's core property, antisymmetry, which ensures that the resulting vector remains outside the span of its inputs. The sequence then moves to visual verification, where the engine is seen in action, dynamically adjusting a perpendicular vector as other lines rotate in space. From there, the diagram scales this logic into differential geometry, where it identifies the unit normal to complex surfaces, and eventually into relativistic physics, where it allows complex electromagnetic equations to collapse into elegant geometric identities. Complementing this flow, the state diagram focuses on the shifting states of our understanding, bridging the gap between seeing, doing, and synthesizing. It highlights how the derivation sheet serves as a purposeful bridge between a visual demonstration and a practical application. For instance, once we visually confirm that the engine works in 3 dimensions, the state diagram transitions us to higher dimensional calculus to calculate things like the flux of wind passing through a sail. This diagram culminates in a duality synthesis, an aha moment, where the derivation's logic reveals that electricity and magnetism are not separate forces, but rather orthogonal rotations of each other in a 4-dimensional world. Ultimately, the significance of the derivation sheet is that it provides the geometrical bridge used in both diagrams. Whether the goal is to find the up direction on a curved 3-dimensional surface or to swap the roles of electric and magnetic fields in deep space, the derivation remains the constant, universal engine that allows us to escape a subspace and see the full picture of the manifold or the field.